Hello everyone. In today's class, we will solve the one of the question of RTU 2016 paper from third unit, that is electric power plant. The question is given like that: a turbine is operated under a head of 24 meter and 200 rpm. The discharge is 8.5 meter cube per second. And if the overall efficiency is 88%, determine first is power generated, second is specific speed of the turbine, and third is type of the turbine. So to solve this question, first write the given data. Given data is head h is equal to 24 meter, n is equal to 200 rpm, q is equal to 8.5 meter cube per second, and overall efficiency is 88% is given. Formulas for this question is overall efficiency equal to shaft power divided by water power equal to P upon rho QGH, and water power is equal to rho QGH divided by 1000, where rho is equal to density of the water, and here in overall efficiency formula P is equal to shaft power, and another formula we use is specific speed of the turbine equal to N under root P divided by H to the power 5 by 4. First, we have to calculate power generated, that is shaft power we have to calculate. So for that we first calculate water power, and by putting all the values of this rho GQH in this formula, we can calculate and find that water power equal to 2001.24 kilowatt. So power generated equal to P equal to overall efficiency into water power. Overall efficiency is given 0.88, and water power we just now calculated 2001.24 kilowatt. So shaft power equal to 1761.09 kilowatt. This is the answer. Second, we need to calculate the specific speed of the turbine, that is ns equal to n under root p divided by h to the power 5 by 4. In this formula, p we just now calculated, that is shaft power. So by putting all the values here, n is equal to 200, p 1761.09, and h is equal to head is 24. So our final answer is 158. This is unitless value. Third is which type of turbine is used here. So here given operating head is 24 meter and calculated specific speed is 158. So these both data indicate toward a criteria of a low head and medium specific speed turbine. For reference, we can use this table from this book. So we can find that this turbine is medium speed Francis turbine, and head is in between this, and our specific speed is in between this limit. So our turbine is Francis turbine.